Satellites. How do they work? Satellites are our eyes in the sky. But how on earth do they stay there? And why do we need them? A satellite is basically a small thing that circles on a much larger thing, like a planet. So Moon is a satellite, and this do we call an artificial satellite. Let's start with a thought experiment. Imagine that you threw a ball. Nothing spectacular would happen, right? It would just fall into the earth due to gravity. However, the harder you throw the ball, the further it will get. But what if you're like Superman and could throw a ball really hard and there would be no air resistance? Then the ball will get really far away from you. But because the earth is a sphere, at one moment there will be no ground under the ball anymore. Due to gravity, the course of the ball will curve, and therefore it will fall around the earth. And that's basically how satellites work. However, in reality it's harder than it seems, since a satellite has to have exactly the right speed. The further it's away from Earth in orbit, the less gravity pulls on it, so the less velocity it has to have. The closer it's to Earth, more gravity pulls on it, so the satellite has to have more velocity. If it's moving too fast, it will fly straight ahead and get lost in space. If it's moving too slow, it will, crash into the Earth. Alright, but when are we using all this strange physics? Well, the question should be, when are we not using satellites? For example, imagine that someone filmed you throwing that ball, and it is broadcasted to the other side of the world. He will send a signal to the satellite, called the uplink. The satellite will thereupon send a signal to the receiver, called the downlink. And as a result of that, someone on the other side of the world could see you throwing a ball. As you can see, the satellite changed the frequency of the message. This is done because otherwise there would occur interference between the two signals and the message would dramatically change. The frequency is higher in the uplink because the higher the frequency, the more energy you need to give it to prevent that parts of the message will disappear because of Earth's atmosphere. To give this energy to the signal is much easier to do on Earth. And what did you thought about GPS? If you want to determine your place on Earth, you need at least 3 satellites. Since you only know the distance between you and the satellite, by multiplying the velocity of the signal by the time it takes the signal to bridge the distance, there's a sphere of possibilities where you could be. If you have 2 satellites, the options are reduced to a circle, and with the 3rd satellite you can reduce it to 2 possibilities. One will be on Earth and the other one will be somewhere out in space. So unless you're lost in space, you will know exactly where you are. Or of course you could use the 4th satellite. And don't forget the weather forecast, keeping track of the planets, all done by satellites. They are part of our daily lives. They are our eyes in the sky.